All right, and in our paragraph proof, we're going to use complete sentences. Now, the reason you would use a paragraph proof is if you were going to publish your proof in a publication, or in a thesis statement, or in a capstone project. I had to do a proof in a capstone project, and I created a paragraph proof, and I got docked points on it because my teacher told me I didn't cite it. He thought I copied it from somewhere. I said, nope, I did it. And he said, oh, cool. And then he gave me my full points back. Okay, but paragraph proofs are when we want to make sure that we're sounding really academic. We want somebody to read through it. We're using those full, complete sentences. So full, complete sentences always start with a capital letter, and they need punctuation. Good. All right, when we do this, we are saying it in order. So I'm going to go back to our proof from yesterday. Let's remind ourselves of what we did here. Look at our order. What was the first thing we stated? The given. Okay, so we'd start with our given, and then next we did that reflexive property. Remember, what does that reflexive property tell us? Good, something's congruent to itself, so that KG was congruent to its KG. And then at this point, at the end, we were able to say these triangles are congruent because side, side, side. So we are going to use our sequential words like first, second, then, next, finally, things like that allows us to show how things are moving as we go. So in our paragraph proof, we're going to just pretty much take each of these points, each of these lines, and we make them into sentences. So since this is a three-step proof, how many sentences are we going to have? 3 sentences. Good. So we're going to start off with something that tells us we're at the beginning. A lot of people like to say first. So first, comma, right? Comma comes after sequential words. We are given AG is congruent to KT. Even though we're writing in words, we can still use our math, our common math language, like the congruent sign and those segment signs. So first we are given that AG is congruent to KT. Congruent signs was not good. Try that one more time. And KA is congruent to TG.
You can also imagine it like writing your procedures in your science class during lab. So when you explain like step by step of what you can do during the procedure section.
Okay, so for our next step, we need a word like a transition word. This one we used first. So what do we want to say after that? We could say second. We could say what? Next. We could say then. Lots of words. I'm going to use next. I like that one. I don't know. Just because it's only 3 steps. Don't really need to keep track of it. Next. All right, and as I look at my second step here, and go back to my second step, what was the next thing that we knew? KG is congruent to KG. So next, we know. Now, anytime we write a paragraph proof, for some reason, we generally use like the we pronouns. We don't say I know or you know. We say the we because we assume that this person's doing the problem with us. Okay, so next we know KG is congruent to KG. That's our statement, but we need to have our reason. And our reason is our why. So what word in a sentence would we use to describe the why? Because of the reflexive property. All right, so one way to do this is you can always do we know this because this. We know this because this. So if that's your sentence frame to just use every time, we know blank because blank. Go with it. However, I find that really boring to read. So those of you that are maybe a little bit more into language arts, you might play around with your sentence structure. And instead, maybe you could start with a reason. But this last step, the next one, is the last one. So how can I show my reader that this is going to be our final step? What word might we use? Finally. What else shows that we're at the end of something? In conclusion. The end. Lastly. Things like that. I like to use therefore. Makes me sound like I'm a really, really good mathematician. Like, therefore. Like, we're coming up with this whole new conclusion. Okay, but we'll use, what do you guys want to use? Lastly, in conclusion, or finally? Finally? Okay, let's use finally. Finally, now we're going to switch this one up a little bit. Instead of saying what we know first, we're going to give our reason first. So finally, using what theorem did we use in our last step yesterday? The side theorem. And yes, we do have to actually spell it out today. Side theorem. Finally, using the side theorem, we know, or we can conclude, or we could even say we can state, we can say, we can conclude. What was our last part that we were trying to conclude in this proof? Good. Triangle AGK is congruent to triangle TKG. Can I just type it in? I don't have mine pulled up yet, sorry. How are you feeling today? Better? Not amazing, but I'll save that. Thank you. Appreciate it. All right. So that's our first type of proof that we're going to talk about is paragraph proof. Now, a paragraph proof, again, really the big reason you would use it is if you are going to go write an article that is going to be in the New York Times. Just kidding. New York Times wouldn't publish a proof. That'd be silly. But also, it's just a good thing to practice our sequential, practicing how we're understanding things or reasons why, because you do that all the time in your language arts class. If you're going to write a paper, you have to have a thesis, right? You guys have heard of that word, thesis? You have to have your statement, and then you have to have your reasons supporting your statement. Okay, so it's just like that. It's just one paragraph. Now, big thing with paragraph proofs is I would personally not be able to, even with this simple proof, it was only 3 steps, and in my brain that's simple because I've been doing proofs forever. Even with this proof, would not go straight to writing these sentences. I have to at least make a small sketch of what a 2-column proof looks like, and then take my 2-column and go to my paragraph. Okay, paragraph proofs are really hard to go to just straight away. All right, we're going to do our second problem, again from yesterday. And on our second problem, we're going to do a flow proof, which I really like flow proofs. I did not learn these when I was in high school, and I wish I would have, because these are my favorite proofs. They're how my brain works. My brain doesn't always think linearly. So the flow proof kind of gives my brain some space to play around and try and mix different parts together. Okay, so let's draw our picture from yesterday, which remember we started with an X. I'm going to draw it a little bit smaller so we have a little bit more space below. And then after that X, we connected it with some triangles. All right, at the top we had F. We had M over here. P, K, and G. So make sure you got that labeled. All right, and again, this is from yesterday, so we're doing the same given and the same proof. We're just showing it two different ways that we can do a proof. So in our given, we know that angle G is congruent to angle M. And we know that K is the midpoint of FP. What we were trying to prove was that FG is congruent to MP. In this one, we're going to do a flow proof. Okay, and a flow proof means that we use arrows to show connections. We use arrows to show connections. So when we started proofs, do you guys remember way back in chapter 2B? Way back in 2B, we had you do these worksheets. And what game did we actually start proofs with? You want to remember? We did these worksheets. We started by playing Uno. Okay, some of you were gone that day, but we started by playing Uno. And in Uno, can you just play your card whenever you want? No, you have to wait your turn. Okay, so 2-column proofs are really great when it's something that has to go in a certain order. Step 1 has to come before step 2. Step 2 has to come before step 3. It's all connected one after the other, after the other, after the other. But sometimes we have these parts where we're coming up with the conclusions. We're grabbing a little bit from here, then we're seeing this over here, and then mix it with this and put them all together. And now we can come up with a conclusion. It's a little bit more like we're grabbing from each part. Okay? So that's why flow proof is a little bit easier, or not easier, but I like it better. It's how my brain works. And not all problems work linearly, where it's one thing leads to the next, leads to the next, leads to the next. Okay, I'll log in. Okay, So we're going to start by saying what we're given. Now, when we're given these angles, give me two. Okay, and again, I'm going to box that because that's a statement. All right, and remember it wasn't connected, so I don't need to draw an arrow connecting these. They just were both our givens. They were both kind of the rules. One rule is not more important than the other rule. They were just part of the problem. So again, what's my reason for K is midpoint of FP? It was given. All right, for our next step, if I go back to our two-column proof, what did we do after our given? Good, FK and KP. When I look back at this, when I look at FK and KP, how did I know that those two parts were congruent? Good. So did I use both of these givens to come up with that conclusion? No. Which one did it come from? Did we know that they are congruent because the angles are congruent or because we have a midpoint? Midpoint. So just from this one, I'm going to draw an arrow to my next reason because it only really comes from that part. That statement leads us to saying that FK is congruent to KP. And this makes it a little bit easier, too, sometimes to see what our reason would be, because it's coming directly from this. So what was that theorem called that went straight from this midpoint to now these parts are congruent? Midpoint theorem. All right, our next idea was that when we look back at this picture, I'm going to try not to go back to the other one real quick. We have angle G was congruent to angle M. And now we know FK is congruent to KP. So we needed either another side or another angle. What was the next angle we came up with? In step number 3, if you need to look back. Yeah, FKG, this inside angle, is congruent to MKP, the other angle. Did that come from the midpoint idea? Did that midpoint lead us to saying these angles are congruent? No, this was a completely different idea, right? Did it come from the idea that G and M are congruent? No, it's just a different idea. This is a whole different thing that we just looked at the picture and we saw it from the picture. So it's going to go off in its own little box over here. It's another little idea. So angle FKG is congruent to angle PKM, or we could say MKP. Okay, and that's its own reason, or own statement. And the reason it's off in its own little world is because the reason for this doesn't come from any of these other parts. This reason comes from the picture, and in the picture, what was our theorem that says that those two angles are the same? Good, vertical angles theorem. All right, now when we look at all three of those parts, do I have enough information to say that these two triangles are congruent? Does it follow the side, 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 angle, angle, or angle, angle, side? Yeah, it's angle, angle, side. So I can say that these triangles are congruent now. So I'm going to say triangle. We said FKG yesterday is congruent to triangle PKM. And what was our theorem for that? Angle, angle, side. So I want to connect those angles and those sides that we stated. So what was one of the angles that we said was congruent? We said GM, right? So that goes here. What's the other angle we said was congruent? Yeah, that FKG and MKP, so that goes here. So that's our two angles. Where does our side come from? Yeah, our midpoint theorem. So all three of those funnel into this theorem that we have angle, angle, side. All right, and then our last step was, because we know that those triangles are congruent, we can finally say that FG is congruent to MP. And this was that really fun theorem yesterday, that weird kind of long letters, the cat pooping one, the one that made me become a teacher. Corresponding parts of congruent triangles are congruent. CPCTC. Cat's pooping carefully in the corner.